So our last video of the year is Boxplots. We're going to start again with a bunch of vocab. So our first vocab word is quartiles. And what quartiles do are divide the data set into 4 equal parts. And what that means is that each part of the data set has the same number of values. And we're going to take a look at displaying the quartiles on a number line. And it may not look like they have the same amount of data because some parts of the data may be more spread out than others. So creating a box and whisker plot, which is what we're going to do today, shows the spread of the data, and it shows the spread of the 4 parts of the data set as well. In order to find the quartiles, your first step is to list the data in numeric order. And then you find the median, which is also called quartile 2. You'll very rarely see that as quartile 2. But that's why we have in step 3 finding quartile 1 by finding the median of the lower half of the data, and then step 4 finding quartile 3, which is the upper half of the data. There's also something called an interquartile range, and what that is quartile 3 minus quartile 1. That's why I typically refer to them. You may also see them as the upper quartile or the lower quartile, which is what LQ and UQ stand for. And what it does is it shows the range of the middle 50% of the data. So if your data set has an outlier, this gives you a different look at the measure of spread because an outlier will affect the range. The 5-number summary are 5 numbers that kind of summarize the data set, and it's the lowest data value, quartile 1, median, quartile 3, and the highest data value. And then finally, like I said, we're going to put it all together with a box and whisker plot, also known as a box plot. And this is a graph or a display of data that shows the 5-number summary on a number line. So our first example, we're 12.4 box plots. Our objective is to create and analyze box plots. And we're going to first look at finding the 5-number summary. So I've got the following data listing song lengths in seconds. So in order to calculate the 5-number summary, the first thing we need to do is put the data set in order. So to save us some time, I already have the data set organized for us. So we've got the lowest data value at 129 and the highest data value at 438. So we have 2 of the 5 numbers for our summary. Then we need to find the median, the middle data value. So I have a median because we have an even number of data values between 221 and 227. So halfway between those two would be 224, would be our median. When you're finding quartile 1 and quartile 3, you do not include the median as part of the data set when you're looking at the lower half and the upper half. So if we had an odd number of data values, and the median was actually one of our data values, we would not count the median when we look at the lower half of the data to find the median again. So now I am just looking at the data set from 129 to 221, and I'm now finding the median of just this data set. It's an odd number, so I have a data value right in the middle, so 171 would be my first quartile. And to find the upper quartile, I would just look at this data set from 227 to 438. Finding the middle number gives me my 3rd quartile. So the 5-number summary would be 129, 171, 224, 344, and 438. All right, so the next example, we're going to calculate the range and the interquartile range and talk about what this means for the spread of the data. So our range would be the greatest data value minus the smallest data value. And we have a range of 309. So what that means is the song lengths vary by 309 seconds, or about 5 minutes almost. The interquartile range would be the 3rd quartile minus the 1st quartile. and we would have an interquartile range of 173. So that would be the middle half of the data. Remember, the quartiles divide the data set into 4 equal parts. So if we don't count the quartiles and we look back up at our data set, we've got 1 part, 2 parts, 3 parts, and 4 parts, and they all have 2 data values. So what this means is the middle half the data, the half the data that's between the 2 quartiles, has a range of about 3 minutes. And what I would say that means is that the data is fairly consistent when I look at the fact that the range is not quite twice as big as the interquartile range, and it should be because the range covers 100% of the data and the interquartile range covers half the data. That means the data set is fairly consistent and we don't most likely have an outlier. I'm just going to jot that real quick. I'm just going to say consistent data. So our last example is creating box plots, and to save us some time, I have the 5 number summaries already for how many hours managers put in a week and how many hours the hourly workers or the regular staff put in each week. And I've created a title for our box plot. I have the number line. Now notice that the number line goes in order. They're spaced at fairly regular intervals, and I am going to label my first box plot. Now I'll show you how I created this box plot with the manager's 5 number summary, and then we'll look at comparing the 2 box plots. So literally, all you do is you just put a point on the number line where the number is. So our first number for the managers is 37. So that would be about here. And then we've got the quartile 1 is 40. Just remember, 5 number summary. So the first number I plotted is the smallest data value in the set. 40 is quartile 1. 45 is our median. 50 is our quartile 3. And 60 is our highest data value. So to create the box plot, you make a box around quartile 1 and quartile 3 with a line going through the median, and then whiskers out to the least and the greatest data values. So I'm going to label this box as well so we can compare the 2 when we talk about them. So to summarize the data, remember, as we look at this, each piece of the box plot shows 25% of the data. So looking at the managers, this would be the first 25% of the data, this would be the second 25%, third 25%, and the upper 25%. So as I'm looking at just this box plot, the upper 25% of the data has a longer reach than the other 3. The other 3 seem fairly consistent, so the spread of the first 75% of the data for managers is fairly consistent, and that longer arm means maybe that 60 is an outlier, or it's just the data is much more spread out in that upper 25%. Again, doing the same thing with the hourly workers. This is the first quarter of the data. Each of the boxes accounts for a quarter of the data, as well as the last whisker. So this time it's the reverse. The first whisker is the longest. So the lower quarter of the data may have an outlier, or it just maybe more spread out than the rest of the data. So comparing these 2 box plots and summarizing the spread of the data, that's what a box plot gives us, is, I would say, for the first, sorry if I'm writing it in red, that would be the hourly. Let's stick with blue for managers. So the first 75% of the data is consistent because each of those boxes or whiskers are about the same length. And the last 25% has a greater spread. Now, because that whisker isn't huge, I would say it's probably not an outlier. Same with the hourly workers. It's just a bit more spread out than the rest of the data. And so then for the hourly workers, it's the reverse. The first 25% of the data is more spread out. And the last 75% is more consistent. All right, so that's a summary of the data sets. I discussed the spread per quartile. It also asked me to discuss the spread of the middle 50% of the data, which for both of those is fairly consistent. So, and we talked about that even though the whiskers are a bit longer, they're not huge, so I don't think there's any outliers. So I'm going to say for both of them, the middle 50% of the data is consistent, or maybe has a consistent spread. And there don't appear to be outliers.